Okay, in this section we're going to take a look at tangent line and normal line. So normal line is kind of a new thing. If you look in this first picture, you're going to see that we have a tangent line that touches when x is 3 and y is 9. So that line is tangent to the curve at that point. Now if we draw a line that is perpendicular to the tangent line, that's what we see over here in this picture. The name of that would be called the normal line. So the normal line is perpendicular to the tangent line. If, for our example, we're given this point 3, 9, we know that's the point of tangency. The slope of that line, well, that's just going to be the derivative. Since the function is x squared, the derivative is just going to be 2x. So that's the slope of the tangent line for any value of x. But our value of x is 3. So we're going to say y prime of 3 is going to be 2 times 3, and so that's 6. Now, if we know that the tangent slope is 6, then we know that the normal slope is going to be negative 1 over 6, just like you see right here. The reason we know that is because perpendicular lines have slopes that when you multiply them, you get negative 1. Another way of saying it is that they are negative reciprocals of each other. So if this one is 6 over 1, then the other one is 1 over 6, but with a negative in front of it. Typically what they're going to ask us to do is find the equation of these lines. Equation of a line, you need a point and you need a slope. And for both of these, we have the point and we have the slope. Okay, for equation of a line, you can see right here, right in the middle. Okay, remember the slope was 6, and this slope was negative 1 over 6. So let's do the equation of a line. Okay, for both of these examples, you can see I'm using 3 for the x, put the 3 here, put the 3 here. And I'm using 9 for the y. So there's my 9, there's my 9, that's the y. The slope here is going to be 6. However, the slope over here is going to be negative 1 over 6. Okay, you could stop there, or you can solve for y. Got to multiply the 6 on both pieces. Add 9 to both sides. Now, before I solve the other one, I want to tell you to be very careful. Do not just change the slope. When you have the slope, when you have the equation of the tangent line, you don't just trade the slope. That's not going to work. What you need to do is what we did over here. Plug in the point, plug in the slope. And when you see when we solve it, we're going to actually have a different y-intercept. It won't be minus 9. So here we go. Distribute the negative 1/6. And add 9 to both sides. Now I'm going to write 9 as 18 halves so I can combine these two. Final answer. I want you to notice that this one had a y-intercept of negative 9, and this one over here has a y-intercept of 19 halves, which is about 9.5. I want you to notice that our two lines are drawn there. They have different y-intercepts. One y-intercept is negative 9, the other one is 19 halves, just like what we have. You'll notice that the tangent line is green, and it does look perpendicular to that purple line, and that purple line we're calling the normal line. Okay, here it wants us to find the equation of the normal line to the graph of y equals x squared that has a slope of 1 over 8. So we're going to start with the easy part. We're going to start with the slope of a tangent line. So for this function, the slope of the tangent line would equal 2x. Now here it's telling us that the slope of the normal line is supposed to be 1 over 8. So that means the slope of the tangent line, which I'm calling m with a little t, that's going to be negative 8 because we do the negative reciprocal. So we can just set these two things equal to each other and solve. If 2x equals negative 8, divide both sides by 2, and x will equal negative 4. So we know that this happens when x equals negative 4. you can plug -4 into your equation, and you would get y is equal to -4 squared, which is 16. Again, we're still trying to find the equation of a line, but it's a line where we know what the slope is and we know what the point is, so we can plug those two things in and get our final answer. Okay, we're going to be using this point and this slope, and we'll plug it into this equation. So the x is going to go right here, the y is going to go right here, and our slope is going to go for the m. Okay, here we go. Plugging in a 16 for the y1, a 1 over 8 for the m, and a -4 for the x1. Since we have minus a negative, that's plus. We can distribute the 1 over 8 on each piece. So the 4 over 8 becomes 1/2. And then we'll also add 16 to both sides. Now, because we have to add the 16 and the 1/2, we're going to write 16 as 32 over 2. Okay, now we can combine these two and we're done. Final answer, we get y equals 1 over 8x plus 33/2. Okay, for some reason this is always the tough one when I put it on the test. This one requires you to solve a system of linear equations. Well, let's have a look. They want you to find the coefficients, the a, the b, and the c. So it's kind of like a puzzle. They give you 2 points that the graph goes through. You have this x squared function. We know it goes through 1, 4, and we know it goes through 2, 16. So let's start by plugging in those 2 points, and that'll give us 2 of our 3 equations that we need. When you have 3 unknowns, you're going to need 3 equations in order to figure out each unknown. So we're going to plug this in. The x is 2 and the y is 16. Because x is 2, you're getting 4 here and you're getting 2 here. Okay, let's do this point. Here we have x is 1 and y is 4. Because x is 1, you get a 1 here and a 1 there. So you end up with just a plus b plus c. Because the y is 4, we're plugging a 4 over here. Now, most students can't get this far, but this is kind of where they get stuck. They don't know what to do next. Okay, we're going to use the fact that this curve and this line are tangent at that point. So that's when x is 1. So if they're tangent at that point, when x is 1, then that means they have the same slope when x is 1. Or another way of saying it, they have the same derivative when x is 1. Okay, if they have the same derivative, then that means the derivative of this one, which is going to give us 2ax plus b, well, that's going to be the same slope as this one. Slope here is just 7. That's how you get the last equation, and that's the one that everyone struggles on. So I can write that over here. Now I want you to notice that this happened when x was 1, so I traded the x for a 1 over here. And so I just got 2a plus b equals 7. Okay, now we want to go ahead and solve these using linear combination. We're going to combine 2 of them at a time. So let me move this one over. You might notice that this one has only an a and a b. So what I could do is I could just do the top minus the bottom, and that will cancel the c. And I want to do that because this one doesn't have a c. So top minus bottom is going to give me this equation right here. Now I can bring this one down under here, combine them again. Again, I can do top minus bottom. This tells me that 5 is equal to a. And now I can start going backwards. If a is 5, I can plug into almost any of these equations. Let's plug into this one. Let's put a 5 for the a right here. That'll give us a 10. Subtract 10 from both sides. Now we found a second letter. We know a, we know b. And to find c, you can plug into any of them that you want. This one looks like the easiest one. So we have 4 equals, the a was 5, the b was -3, and the c is what we're solving for. If we subtract 2 from both sides, we get c equals 2. Now let's go back to the question. We were supposed to find the equation of this parabola. So we needed to find the a, the b, the c. We found them. And let's go ahead and plug them back into the equation. Okay, here we go. Y equals, and the a was 5. So we put 5x squared. The b was minus 3. And the c was 2. And there we go. That's the equation of the parabola.